Have you ever seen those pictures of amazing clouds in the most bizarre colors and shapes? Are you familiar with them? They are known as nebulae. How can we capture these amazing pictures? What makes nebulae significant? Do you know that these are the typical birthplace of stars? Stick with me and I'll tell you everything in a moment. The name of these ethereal objects, nebula, is possibly the most fitting one in all of astronomy because the Latin word literally translates as cloud or fog. In actuality, they are clumps of interstellar dust, hydrogen, helium, and other ionized gases. When were they initially found? Ptolemy used this name for the first time to describe a cluster of 5 stars around 150 AD, most likely without giving it a precise categorization. The Orion Nebula, one of the brightest in the sky, was later made by using a telescope for the first time in 1610. A few words following that, the quantity of sightings increased swiftly and was compiled by William Herschel and his sister Catherine Herschel into a catalog of nebulae and star clusters. The Andromeda Galaxy, which was known as the Andromeda Nebula until the early 20th century, is a notable example of how this concept was wrongly used to represent any type of cloud. The so-called Great Debate actually occurred in 1920, to be more specific. What was the topic? It was focused on the characteristics of a collection of spiral nebulae. There are 2 astronomers named Harlow Shapley and Heber Curtis held opposing opinions regarding the separation between these 2 items, and the scientific community found it difficult to adopt a stance. The first believed that these clouds were barely outside of our Milky Way, whereas the second was certain that they were actually different galaxies rather than nebulae. Edwin Hubble made a significant contribution by measuring the Andromeda Nebula's distance, which allowed researchers to confirm Curtis' assertion that Andromeda was a distinct galaxy. What can be seen in a nebula image? It unquestionably seems to be quite thick and dense, like a cloud of dust. But there is one unexpected outcome. Even though they are denser than the surrounding space, they are so much less dense than the everyday world we live in that any vacuum produced on Earth is unquestionably denser than them. A nebula the size of our globe would only be a few kilograms in weight. How do nebulae in general form? These can be produced by interstellar material, stars, or the remnants of a supernova. In actuality, there are many different kinds of nebulae, depending on how they originate and how the cloud behaves. Do you recognize any of them? Do not worry if not. We'll view the 5 most significant nebula types in this video. Make sure to like or dislike the video before learning more about this so that we can keep improving and making these films better for you, the viewer. Let's start with the Orion Nebula's classification, which was previously indicated. As one of the most well-known HII regions, it is renowned. They are primarily distinguished by the 90% ionized hydrogen content and by their brilliant red color. These 2 concepts are inextricably related since all ionized hot gases emit light at specific wavelengths. The term spectrum in physics refers to the energy emission density per unit of frequency or wavelength, which can be thought of as a list of the radiation's frequencies. The emission spectrum of an ionized gas is what it's called, and it primarily consists of a few lines that are unique to each element. Let me check to see whether you understood what I said. Do you know what color the H-alpha emission line of hydrogen, which is almost around the value of 656.3 nanometers, corresponds to? Red, that's right. Due to the presence of its ionized hydrogen, HII appear red. But why is there this ionization in the first place? These regions contain an enormous number of blue stars with brief lives, which brighten the gas generating the emission lines. But where do these particular nebulae tend to be found? Have you ever seen those stunning pictures of spiral galaxies, such as Andromeda or the Milky Way? The majority of HII regions are located in the usual branches of these structures. Although these nebulae have the capacity to produce thousands of blue stars over the course of 1,000,000 years, they are typically scattered by supernova explosions, which take place when a truly big star is nearing the end of its existence. The planetary nebula is the second type we'll talk about. Don't be misled by the name, there is no connection to planets. This definition, provided by William Herschel, results from the object's spherical form. In reality, the Ring Nebula was characterized as being extremely dim but precisely delineated. It is as massive as Jupiter and resembles a dying planet by French astronomer Antoine Darquier de Pellepoix in 1979. The remains of a supernova, including intermediate stars, created these specific nebulae between 1 and 8 solar masses. These final ones, like the Sun, spend a significant portion of their existence turning hydrogen into helium, a phase also referred to the main sequence, which is eventually transformed into carbon and oxygen. The asymptotic gigantic branch phase is the name of the second stage of nuclear fusion. In both situations, the star's reaction produces an outward pressure to counteract the gravitational contraction. Due to stellar wind, the star loses masses during the giant branch era. The stellar hydrogen and helium burning shells, which can reach temperatures of about 30,000 K, can illuminate these components released by the star's environs, an appropriate temperature to emit ionizing ultraviolet rays. Planetary nebulae die in what manner? The nuclear fusion is stopped when the star's core runs out of energy to convert oxygen after consuming all of the helium in the star's core. As a result, no more UV radiation is created, and because the gases aren't ionized, the nebula fades away and becomes invisible to us. Are you aware of how significant planetary nebulae are? Why? Metals produced by the star are quite abundant in these clouds. In contrast to the universe, which is typically made up of hydrogen and helium, these elements are not very common. Moreover, planetary nebulae are unquestionably the most varied and stunning ones, featuring an array of brilliant hues and bizarre shapes. Do you need an illustration? Look for the Ring Nebula or the Cat's Eye Nebula. The following are the results of a survey conducted by the National Institute of Standards and Technology, NIST. They are made of ionized gas, which emits light at various wavelengths depending on the cloud's constituents. Now let's look at the reflection nebula, which is the third variety. These nebulae do not produce radiation on their own, in contrast to emission nebulae. They only mirror the light from an outside star, as their name implies. Do you desire a straightforward comparison? When you look at a marble cave, you are blinded by the light that emanates from the rock, yet this radiation is not created by the marble itself. Rather, it is just sunlight that has been reflected and is being focused on our eyes. The brightest stars in the Pleiades cluster, one of the most noticeable ones, are surrounded by the most well-known reflection nebulae. Blue light is always produced by this kind of scattering since the reflection is more effective at this wavelength. Often, when we have a particle considerably smaller than the wavelength of the radiation, this process, also known as Rayleigh scattering, after the 19th century British physicist Lord Rayleigh, occurs. It is feasible to discover that the power of light diffusion is inversely proportional to 4. Due to this, blue, which has a shorter wavelength of 500 to 520 nanometers, is heavily reflected compared to red, which has a greater wavelength of 700 nanometers. As a result of Rayleigh scattering, which describes how the particles in our atmosphere interact with sunlight, this is the main cause of the blue color of our sky. In reflection nebulae, the exact same thing happens. Black nebulae, in contrast to these latter ones, are described as black and gray clouds that infrequently reflect the light of other stars. They can also be known as absorption nebulae, which is a moniker that unmistakably conveys their primary attribute. In actuality, they don't emit or disperse any sort of visible light. Only other frequencies, like microwave or infrared, may be used to observe their molecular hydrogen and helium composition. They typically block the view of a reflection or backward emission nebula. These nebulae are most likely the densest in the entire universe, and the largest known dark nebulae, known as giant molecular clouds, have an absurdly long diameter of 150 light-years. Thus, if you were to go through the entire cloud at the speed of light, it would take you close to 150 years to do so. This distance is completely absurd when compared to our own solar system, which is only 2 light-years away. And that's not the end of it. Do you like to learn more fascinating information about dark nebulae? They are among the universe's coldest things, with a very low temperature of 10 K, or almost minus 263 OC. Also, it has been hypothesized that this nebula's center may be a site of stellar creation. A black nebula's structure and shape can be quite fascinating. Have you ever seen the startling image of the horse-like dust clouds? That is the Black Horse-Head Nebula in the constellation of Orion. The last, but not least, category of nebulae, supernova remnants, brings an end to our tour of them. They are created by the explosion of a supernova. We can get at such an energetic phenomenon via 2 distinct routes: neutron stars and black holes. The first one is arguably the most well-known astronomical object. It is an incredibly dense mass of matter with a gravitational field so powerful that neither light can escape its pull. On the other hand, neutron stars, which have a central core made of decayed neutrons, are both visible and extremely dense. What does this word signify as an adjective? Due to the close proximity of the particles, a peculiar quantum phenomenon occurs. The star's core produces degeneration pressure, which counteracts the star's intense gravitational contraction and prevents the star from collapsing. Both of these objects are the byproducts of enormous stars, more than 8 solar masses, that have completed nuclear fusion in their cores and collapsed. The supernova is created when a star collapses and material is ejected, creating a shock wave. The leftovers from this enormous event are accelerated to a breathtaking 30,000 kilometers per second, 10% the speed of light. As time, the components slow down to the speed of sound, and they produce this unique type of nebula, which is regarded the main source of cosmic rays. Are you familiar with them? These are particle beams that originate in many places and go to the planet. Please watch another video on this channel where we discuss cosmic rays in greater detail if you want to learn more about that. The Crab Nebula, a magnificent cloud where we can clearly see the supernova's debris, is arguably the most well-known supernova remnant. In conclusion, we have seen a vast range of nebulae with various origins and compositions. What at first glance appeared to be only a dense cloud in space turned out to be concealing some crucial elements for star formation study. Here's where the video ends. Thank you everybody for watching. Are you intrigued by this subject? Do you find the variety of nebulae we can see to be amazing? Did you know that nebulae are the birthplace of many stars? Ever catch a glimpse of one of them? What kind of nebula do you prefer to look at? Please share your thoughts in the comments section below. Don't forget to subscribe, and I'll see you on the channel again soon.